Bomb dear guys, how you all doing? So in this video I'll be talking about explaining the derivative in terms of the limit function, and this is the true definition of a derivative. So just to make note, once you know the most basic definitions and formulas and rules, then in any ways you can compute derivatives using what we already know. So first things first, so what is the geometric meaning of derivative? Well, we know that the f prime x, which means the first derivative, equals the d over dx, which is a derivative respect to x, and at the function fx, and this is really the slope of the line tangent to y, which y equals fx. So this is also the tangent y equals fx, the slope of the line tangent to y equals fx at point x. Okay, so let's use this diagram I drew. So I want to draw a nice little graph which might illustrate. Okay, so using my amazing ruler, we need to draw a slope at point P. So I'm going to call this one point P. Okay, and suppose at point Q, this will be a change. So let's call this value x. Okay, and this one fx, another fx. So this is just a function. Now point Q, what we have here is the change of x, is the original x plus the change of it. So we call this x plus the change of x. Delta x means the change. Likewise here, at this point, this will be the same thing. This will be fx, the function of x plus the change of x. So this, the function is equal to x at the point x at the change of x, which is relative to this one. Same to that one. And now, what do we have here exactly? Well, if you can think of it geometrically, what we have here is a slope. At this point, the derivative, in fact, is a slope that cuts through P and cuts through Q. So you see this curve, some sort of quadratic. Okay, this would be the slope. And the second line, this is the second line, through P and Q has a slope, and this slope would be defined here by, so think of it like this. So we'll go find the difference here. So the difference of this line over the difference of this line. So it'll be fx plus delta x minus fx over, and then these two, x plus delta x minus x. And what does it simplify to? Well, the top line is the same, the bottom line, the x is cancelled out. So we're going to have fx plus delta x minus fx all over, and this cancels out, delta x. And this, my guys, here, we can approximate this, the tangent line, which is the tangent line, through P by moving Q towards P. So in other words, when this goes towards Q, differentiating, this would decrease the delta x value. In other words, yeah, this is where the limit definition comes in. Once we set the limit value of this, send this to 0, then we have a derivative function. Okay, so enough yabbering about. Let me just write this on this side. So what I'm trying to say here, this is the point where we have the limit. So we say the limit as delta x, so the bottom value, the fraction, as that tends to 0. So the function was fx plus delta x minus fx over delta x. Now, as this tends to 0, this would therefore equal the true definition of a derivative. And this is really how it works. Now, the truth is, taking delta at point 0, you get 0. But the truth is, as it approaches 0, you get the true definition of the derivative. If the limit as delta x approaches 0 at a particular point does not exist, then of course we say that this is undefined at that point. So this is quite clear. Now let's use an actual example, okay, to see how this definition works. So guys, good that you followed me up to this far, up to this point. So let's try an actual example, okay? So the limit definition of a derivative. Suppose we have something we know how to differentiate. So let fx equal x squared. Okay, so now using the definition of a derivative, we know how to differentiate this. We want to prove, using the definition of limit, that prove that the derivative equals 2x, since we can obviously see it is. So using the formula, f prime x equals the limit as delta x approaches 0 of function again fx plus delta x. So this is the change, fx plus delta x minus, and this would be the function x over delta x. Now replacing fx with x squared, so this would therefore be x plus delta x squared. So what do we have? The limit as delta x approaches 0 of, this would be x plus delta x all squared. Think about it. This x is now replaced as x plus delta x, the function, minus x squared over delta x. And expanding this quadratic expression, what do we have? So we have now, so guys, when you take the limits, you always have to keep writing the limit numerous times. Let's expand this here. What do we get? We get x squared plus 2 times delta x times x plus delta x squared minus x squared over delta x. Okay, so we're near the end of this, so let's try and simplify the top line. What we have here, these two cancel out, and notice that we still have delta x on each term, so we can cancel this, 1 delta x and 1 delta x here. So what we're really left with at this point, tidying this up, we're left with 2x plus delta x. Now, taking a limit as delta x approaches 0, this is very easy. This part would just be 0, so we're left with 2x. And that's it, guys. This is the definition of limit. I hope you understood everything I've been saying at this point. And of course, this is exactly what we expected. Now, there's more examples of fractions as well, but we'll probably cover that next time. Okay? So thanks, guys. Hope this helps, and leave a comment below, subscribe, and let me know anything else. Take care.